Hello everybody. Today we're going to talk about centers and measures of the center. That means we're going to take a look at a data set, and for example, we're going to click on the treadmill tab. I'm going to copy and paste this over to another tab like I've already set up, and we're just going to play around with the idea of the measures of center. So what are the measures of center? What does that mean? Well, in this case, it comes down to three words we typically use, which is the mean, the median, and the mode. So how can one find these values? That is a great question. For example, what we have here is data on a customer data on who has bought a certain product, a certain type of treadmill, versus their age, their gender, so on and so forth. And I would love to know what is the average age of a buyer of this type of treadmill. That would be a great question to answer. Or what is the median age? Or what is the most popular age? The mode. So how could one do that? Well, let's talk about that. First of all, I'm going to copy this over to a new tab so I can completely destroy it. And if I need it back, I can go back to the previous. So let me destroy these variables for now. I'm going to focus on product and age right now. All right. Now there is two types of products, so we could really focus on both products and compare and contrast them with the age. In fact, let's do that. So first thing I'm going to do is I'm going to do a custom sort. Make sure my data has headers, and I've highlighted the daters, and I click product. So my data has headers. Clicked on product to sort that first, and then I'm going to add a level, and then I'm going to sort on age, lowest small, or smallest to largest. Click, and everything should be sorted now. All right, so here's what I'd like to do. I'd love to find about the mean of the customers that love the T195. And then, of course, there's another product down here, the 498, and then the 798. We could do it a few ways here. What I'm going to do right now is splice, that is cut it, and paste this data. So that way I have the 195, the 498, and the 798 all next to each other. I like to show you how I prep the data. I know it slows down the discussion, but it's important to understand how to take a look at the product, age, if you are trying to look at averages. Now, of course, there are many quick ways to get to the age. I'm here to help you really understand what it means to be the mean, the median, and the mode. So let's say we're looking at the TM195 or the TM498. We have three products here, or the TM798. All right. So first, what do I want? I want the mean, then I want the median, and I want the mode if it exists. So I'd love to fill in this little box I'm making so I can kind of compare and contrast the mean, median, and mode for these data sets. All right, to do that, to find the mean, you just got to think about what the mean is. The mean is adding up all these and then dividing by the count, right? It's adding up the ages, all the ages, and dividing by the count. That's what the mean is. So pretty much you would add these all up and divide by the count. The good news is the mean is quickly found in Excel. If you look at the command equals average, it will open the parentheses, it will, whatever numbers you highlight, it will average them out. Close the parentheses. Click enter, and we find the average age for the users of the TM195 is 28.55 years. Again, remember averages, add all the numbers together and divide by the count, that is n. I'm shortcutting to the formula right now. I would expect if you could do this by hand, you should be able to do this by hand, which is, again, you would add all these numbers up and divide by the number, the count here, which would be 60 of them. I'm just doing a little faster, helping you out with a nice little command in Excel called the average command. The average command does the formula for you. Again, takes all the numbers, adds them up, and divide by the count. Awesome. And just as an extra little cool feature, we could find n, that is the count. I want to make sure we are very clear on the letters, because as we get into more advanced statistics, I like to make sure we understand what each letter represents. Well, the cool thing, there is a count function. It counts the number of cells in the range. So we can highlight the data and we can say count these numbers, and it will count it for us. Now I know that seems kind of silly when we could just go down to the bottom and see 81, and 81 minus 1 would be 80. I understand that. And you might be saying, why are we subtracting 1? Very good question. I hope you understand we don't have data in the first row, so whatever number we go down to, it's got to be minus 1 because of the headers we have. Equals count, though. It's good to learn about some of the Excel codes that you can get friendly with that and use and really help your life nice and easy to make your life. That is, to count, it just counts up the numbers for you. And in that case, there are 60 of them. In case you were wondering, how many numbers do we have in each of the boxes, in each of the products? So I can see we have 80 TM195s, 60 498s, and 40 798s. It probably would have been better if I had put those on top of there, as I just realized. This is not a good labeling. So I would put the 80 here, the 60, and the 40, just so I know this is my count over here, and not put it here. Excellent. So what we have here is a nice little display of information we're getting. All right, so we have the mean. Again, the mean is add up all the numbers and divide by n. Notice the mean age for each one of these treadmill buyers, purchasers, is roughly the same. There's not much difference. Okay, that's cool. Let's look at the median now. Who would be the middle person, the median? Well, the middle person, now these are all even numbers, so we have to pause. If these were odd numbers, if the counts are odds, this would be easy, because odds, that means there's somebody directly in the middle. These are not odd numbers, these are even numbers. Even number means we need to go halfway to them. So 80 means we got to go to 40. So if these are in order, like we did, we would go to person 41 and 42 and average them. All right. The median would be directly in the middle of 41 and 42. Now, 41 and 42 represent position 40 and 41, of course. Remember, we have headers, so you got to be careful of that. Think about where 80 is, how you would cut 80 in half. If you cut 80 in half, you'd have the first 40 and then the next 40. So that a nice halfway between an 80 would be 40 to 41. And that's what represents those two numbers. But good news, Excel has your back. If it goes equals median, it returns the middle number. But I want you to understand what the median is. The median is the middle. Now, you got to be careful, because if the data is not in order, you could get screwed. That is, if the data is not in order, and I do my little procedure like this, if I go down, so this is 60 now, my count is 60, I know I would go down to number 31, so number 31, and I know that numbers 31 and 32, I would find the median of those. But if this data was not sorted, then who knows what the two numbers would be in these two boxes. All right, you have to sort the data. This is very important. That's why I did it in the very beginning. Let's make sure, once again, I picked off the median correct. The median is sort the data and find the number that is in the middle. If it's an even set, there's no true middle, so you average the two numbers that represent the middle. So same thing here, we would go to 21 and 22, and the median here should be 27. Check that out. At any time you need, please pause the video and try this out with the data set, all right? If you like this data set that I'm working with, just let me know, and I'll be happy to supply this data set. It's free of use, no big deal. I want people to be able to enjoy these videos and practice with me. That's what I hope you do, is you practice these videos with me to get used to and understand what the mean, median, and mode represent. So the mean is the average if I add them all up and divide by the count. The median is the middlemost point. Notice the mean for each one of these is slightly higher than the median. What does that tell me? Well, it tells me a little bit about the shape, okay? Notice for each one of these, the mean is above the median. What that tells me is there's more higher end people kind of dragging the mean towards them. All right, think about that. The median is in the middle, regardless of who is higher or lower. That's where the median is, right in the middle. But the mean seems to travel with the higher people. Think about it in terms of grades. The higher the grades are, the higher the mean goes up. All right, let's look for the mode. All right, well, the mode would be the number that appears the most often. So, good news, Excel has the ability to find the mode. But there is an issue with the mode. When you highlight the data, it'll look for the mode, but if there's two modes that are the same, if it's bimodal, it'll only pick the first pair. So for example, 23 has, and this is kind of cut off so I can't see, looks like there's 6 of them there. 3, 6, 8, I apologize. 3, 6, 8. There's 8 23s. If there was another set of 8, Excel would miss that. 1, 2, 3, 4, 5, 6, 7. That's 7. 1, 2, 3, 4, 5, 6. I don't think there's another pack of 8. Excel only gives you the first of the modes. So if it's bimodal, it'll miss that. So you got to be careful of the mode function. Again, the mode function, what it does is it scans through the set and it finds the number that appears the most often. But there is one issue in Excel. If there are 2 modes exactly the same, or mode, if you have 3 modes exactly the same, it will only pick off the first one. So you got to be careful again if you're using the mode function that you will definitely have the mode and only the one mode. So again, look at 25. There are 3, 6, 7 numbers. I don't think there's any more with 7. So this would be the true mode. But we always got to be careful in case there's another set in here that repeats the same amount. All right, now that we've collected what I call the measures of center, there are 3 types of measures I use for the center: the mean, the median, and the mode. I don't look at the mode too often. Really, the mode is great when I have qualitative data. If I have qualitative data, that's the only center I use. If I'm looking at ethnicity, if I'm looking at gender, I'm looking at mode, the most often responded. When I'm looking at quantitative data, I look at the mean and median. The mean is the most important number to me, but I also use the median if there are outliers. In future videos, we'll discuss what it takes to be an outlier. And so what we do here is we make sure that our mean and median are relatively close to each other. So that way we can pretty be sure that there is no outliers. If the mean and median are pretty far apart, there is a high indication that there could be an outlier. But again, until further discussion, we really can't talk about outliers. All right, so what we have right now are the measures of center. That's what these call the mean, median, and mode. And in fact, let me put that up higher. So the measures of center, these 3 numbers. There are others too. So we have the mean, median, mode are measures of center. Awesome. So that gives me the center of the data. And we can talk about, again, what's the average age who buys a certain type of treadmill? What is the median age that buys a treadmill? Honestly, I don't see much difference between the mean and median. So both are great numbers to report. And honestly, between each one of the treadmills, there's not much of a difference. So as we're trying to look at these, I like to compare, once we have all the data, I like to compare and contrast the data. I'm looking for irregularities. I'm looking for something where I could tell my manager to say, hey, look here, we have more people buying this, younger people buying this, older people buying this. But right now, all I see is pretty much the mean age is roughly the same and the median age is roughly the same. Okay, but that's not the whole story. Once we know the mean, median, and mode, that's great. We have the center. What I would love now is I'd love to talk about the spread. Well, the first number to get the spread would just be the range. So to get the range, it's pretty easy. It's the high minus low. You could scan the list, get the highest number, get the lowest number, and you're good. I want to teach you some commands. So we have the max command, which obviously finds the max in the list. I always want to make sure you understand some of the simple commands in Excel. So max finds the maximum number in the list. And there you have it, 50. I'm now going to update this formula by minus min, which finds the smallest number in this list. And max minus min is the range. And so the range of the TM 195, so treadmill 195 types, is 32. Now, of course, as one would think, there might be a range function. No, I didn't find it. So I'm not seeing range. All right, so we'll have to do max minus min again. No problem with that. We can find the max command minus the min command for this set. At any time you need, pause the video and make sure the code makes sense to you. Max minus min is the range. Just got to know that. The range is the first chance for us to see how the data is spread. It's a quick and dirty way to look at the spread of the data. So the range is great. There are some problems with the range. The biggest problem is an outlier. An outlier will really destroy the data set, will really destroy your range. All right, think about this. If everybody's test score were 80 except one person that got a 30, the range would be 80 minus 30, which is 50. So I would think the range of scores would be 50 in points. But truly it's not. The range is 0 because everybody got 80s except for one person. Or, exactly 80 is what I'm saying. So we have to be careful when we're looking at the range because an outlier can really throw off the range. I always be careful, and honestly, besides doing what I call here the descriptive statistics, a picture is a must for each one of these. A box plot or a histogram is a must for each one of these to see if you have outliers, to see if you have a skewness. Yes, we are playing around with measures of center and now measures of spread, but we should always be careful to make sure of any interesting identification or spots in the graphs, that is the histograms or box plots. All right, so the range is not the greatest. So we move on to this thing called the variance. And then from there, we'll move on to the standard deviation. So how does one find the variance and how does one find the standard deviation and what do they mean? Great questions. So here's what we need to do. We are going to need to insert a few rows. Even though I say rows, those are columns. Because we're going to do some work here to find the variance. Now, yes, I know there are shorthand formulas, so we could check them as we do. There is and equals variance. And you got to be careful. You got to read, because there are there's a bunch of types of variance. There's a variance if you believe you have the population. That means you collected all the data. There's also a variance formula if you have a sample. Most of the time, we are going to work with samples. How do you know if you have a population? Read carefully. If you're the one doing the study, then you'll know if you've collected the data on every single possible person in your study. If you didn't collect all data points for every single person in the study, then you have a sample. And var.s will easily get you the sample variation. So there is the sample variation for this age group, for this product, the TM195. There is the variance. Now, how does one get this by hand? I like showing it by hand because it really brings out what it means to be spread. So first of all, the first thing you do is you find a deviation. So what is a deviation? A deviation is how far each data point is away from the average. It's a good thing we figured out what the average was. So we go equals the data point minus the average. Make sure you click the right average you're working with. Click. So now, what does this number represent? This number represents 18 is 10.55 points below average. If this is the average age, if an 18-year-old wants to buy it, they're just over 10 years away from the average age that buys it. Now, I'd love to move this formula down, but there's an issue with this formula to do that. If you want a number not to move, you have to make it absolute reference. And to do that, you put dollar signs around the letter. The dollar signs around the letter will freeze that cell. So in this case, the 28.55, I don't want to move. It is the same average all the way down. I want to take all these numbers minus this average. And this formula will do this. So now I could just double click and it fills it all in for us. Notice it starts out negative and turns to positive. Because my data is sorted, that's what it's doing. Notice we get 21 points above average. Well, remember, the average is close to 28. And so a person that's 50 is 21 each points above average. That's their deviation. Now, one would think the deviation sounds great. The problem with the deviation is when you try to add up the deviation, when you try to quickly sum up the deviation, so equal sum, add up the deviation, you get a little issue, or a checkpoint as I call it. The number will always be close to zero. And this number, and you need to pause for a second and see that, this number is really, really close to zero. When you see an E negative, E means exponent. It really means powers of 10. That negative represents decimal shifts to the left. So we are 13 decimals deep before we see a 5. That is 12 zeros and then a 5. So we're really, really small, close to zero. This happens all the time because what the definition of average is. So what we do is we now square the deviation. Deviation squared. All right, that's no big deal. If we have the deviation, I can use the caret symbol and square it. Now you may say, why would you square it? Well, to get rid of the negative positive issue. Now it's always completely positive. It's always completely positive when we add these up. And yes, the sum, and that's not the sum, we need the sum here, the sum will be pretty large. The sum of the deviation squared will be very, very large. All right, that's the sums of the deviation squared. So that's what we got there. We got the sum of this column. All right, so we're actually really close to the variance. The variance is the average of the deviation squared. All right, the variance is the average of the deviation squared, but with one caveat. Because we're a sample, we're not going to divide by n, but we're going to divide by n minus 1. So I can't just use the average here. I have to be careful. The variance is the average of the deviation squared, but you have to divide by n minus 1. So what we do is we sum up the deviation squared, and then we divide that number by n minus 1. In this case, remember, n was 80, so we divide by n minus 1, which is 79. So our variance is 52,149, which is the number that's reported right here. Again, the variance is the average of the squares of the deviations. And so what happens is we add them up, so we get the sum of the squares of the deviation. That's what this is, the sum of the squares of the deviation. And then we divide by n minus 1. We divide by n minus 1 to make sure the value is unbiased. We talk about unbiased in the graduate study, so we're going to leave that for you to research if you like. Right now, just understand if you have a sample, the variance is the sum of this column divided by n minus 1, where n is the count. All right, we got the variance. The problem with this is it's square units. Think about it. We squared the units. So this is really squared age. That's what the variance is. It's the average of the squared age. That's a weird thing to say. The variance is the average of the squared age. I don't like that. So instead, I want the standard deviation. So to find the standard deviation, I would take the square root, SQRT, the square root of the variance. And by definition, that is the standard deviation. So the standard deviation of the TM195 is 7.22 in years. They all would have to be in the same units here. These are years. That is mean, median, mode is years. The range would be years. The variance wouldn't. The variance would be square years because we squared, remember. To get rid of a square, you would square root. And so the standard deviation is the square root of the variance. We often don't look at the variance, but we need the variance to get to the standard deviation. Now that we found the variance by hand once, I'm going to utilize our beautiful Excel for what it does. We can find the variance of a sample by var.s. And that's what I'm using. I would ask that you pause my video and see if you can get the variances by hand by making the columns like I did. So you really understand what the variance is. It is the average of the squared deviations. It really is a measure of spread because we're looking how far each data point deviates from the average. We have to square it to make sure we get some kind of value that makes sense. And these are if we sum this up, we're getting close to an average, right? When we sum this up, we're getting close to an average. So if we divide by n minus 1, we are really getting a so-called average. That average is called the variance in this case, the average squared distance. To get rid of the word squared, this would be standard deviation, and to me, this would be the average distance spread. That's what I think that. To find the standard deviation, once again, it's the square root of the variance. These are all formulas that you just got to get used to, or you write down on a cheat sheet and say to yourself, the standard deviation is the square root of variance. And there we have the standard deviations. All these numbers are measures of spread. Cool. And so what we have here is a really nice display of descriptive statistics. We have the measures of center and we have the measures of spread. So in our next video, we're going to talk about position, the z-score and position. So we're going to use this exact same data set right here. Before I move on, I want you to understand I have used a bunch of Excel codes. The average command to find the mean, the median command to find the center, the mode command to find the center. But understand again, if there are two modes bimodal, it will pick off the first mode only. How do you make sure you don't make this mistake? I would draw a diagram like a box plot or a histogram to help. Histogram is better for modes. What else do you have? Well, you can find the range, and you got to understand how to find the range via the max minus the min. That's a good definition. The variance, it's got a simple command in Excel, var.s. You could, of course, also find the variance by what I've done in this video. Standard deviation is just the square root of variance, so all I do is take the square root of variance. Now, yes, if you're keen, you're probably thinking, is there a standard deviation formula? And as I start typing, that's a great thing about the new Excels, it starts popping up special standard deviations. Again, if you have the population, here's that special standard deviation. If you have a sample like we do, here's your standard deviation formula. Oops. And of course, you just got to do it right. Stdev.s. What I would do is make a quick sheet of formulas that you use in your job. So if I want the standard deviation, I know quickly it's Stdev.s of that number. And it matches perfectly the number I got. So you can quickly get the standard deviation without going through the variance. That's true. I'm here to teach you some of the basics of these formulas and what they mean. All right, one more thing before I go. It would have been great if I could have gotten all 6 of these numbers quick and fast. And that's why I love putting it at the end of this video, because I know people are like, what? The answer is yes. I could have easily gotten all these numbers quick and dirty. Thank you, Excel, for making that possible. What I'm going to do is in data, so make sure you get the data analysis package loaded. If not, pause this video. All right, welcome back. Now that you have data analysis and you found it and you loaded it, sometimes you have to load it, I want the Descriptive Statistics tool. Click on it. It asks me, what numbers do you want me to build the descriptive statistics on? Well, highlight the numbers. There they are. Beautiful. Where do you want me to output my beautiful summary? I want it right close to here so I can see it. You can change what it does in here if you like. I don't. And please click Summary Statistics. It won't actually show you the summary statistics if you don't click that box. So 3 things. Input the numbers you wanted to summarize. Tell you where the summary should go. Please make bottom and right empty. Make sure bottom and right is empty because that's where it'll dump the information. And then click Summary Statistics. And away we go. And what we get here is a quick and dirty way of finding the summary statistics for the TM195. That is, we have the mean. Oh, look, it matches 28.55. We have the median, 26. We have the mode, 23. We have the range, 32. We have the standard deviation, 7.22. We have the sample variance, 52.149. So think about that. Think about what you get for free that I just spent 30 minutes discussing with you. That's the great thing about Excel. And in fact, we talked about all of these down here also. But it's great to back up what we've worked on. It's very important to me that you have working knowledge of the things I've highlighted in yellow. In our next video, which is called Position, I'll talk about the other pieces so we can clearly understand what everything is in this descriptive statistics box. Thank you guys for watching this video. Stay tuned for more.